Hey guys, it's Ms. Brown. Obviously not there with you today, so we have another recorded lesson. You'll have one today, one tomorrow, one Monday, and then I'll be back on Tuesday. This is my cat's tail. Sorry, but she won't move. We'll work around her. We're on lesson 12 today. The page number is on your daily activities page. I don't have my book on me, so go ahead and get there. If you need to pause, go ahead and pause. So today we will model the distributive property, and you will write expressions using the distributive property. Let me see if I can zoom in on this a little bit so we can see better. There we go. That looks good. All right, for the opening exercise, we're going to create models to show multiplication. I'm going to do the first model, and then I want you to pause and then come back after the second model. So we're going to create a model that shows 2 times 5. 2 groups of 5. Remember, the multiplication symbol just means groups of. So here's our 2. Okay, I got my 2 groups. It's 2 groups of 5. Pretty easy. Take a second, pause, do B by yourself, and then play the video. All right, now that you've had a pause, your diagram should look something like this. 2 groups of B. Pretty simple. All right, our next section here, we're going to write an expression that is equivalent to 2A plus B. Okay, when we have parentheses and a number on the outside, that means that everything in that pair of parentheses is going to be multiplied by that number. So let's take this number from the outside and multiply it by everything on the inside. Okay, so we'll have 2A and 2B, but that operation in the middle here stays the same. So 2A plus 2B. Okay, cool. Create a model to represent A plus B. Okay, this would be A plus B. Just like up here, 2 groups of 5 would have been 5 plus 5. If it had been 3 times 5, we would have 3 groups of 5. Be 5 plus 5 plus 5, because multiplication is just repeated addition. Okay, here's our model representing A plus B. The expression 2 parentheses A plus B parentheses tells us that we have 2 of the A plus B's. Create a model that shows 2 groups of A plus B. So 2 groups of A plus B would just be A, B, A, B. It'd be 2 of what we did before. Now, how many A's and B's do you see in the diagram? We see 2 A's, 2 B's. How would the model look if we grouped the A's and grouped the B's together? So that would just change our model to AA, B, B. We can move those around because of the distributive property of multiplication and addition. What expression could we write to represent the new diagram? 2A plus 2B. That's the same expression I gave you earlier. So all we've done here is modeled it to show how we got it. What conclusion can we draw from the models about equivalent expressions? Well, we can say that what we started with, which was 2A plus B in parentheses, is equivalent to 2A plus 2B. Okay. Now, if A equals 3 and B equals 4, what's going to happen? Well, we'll start this way. 2, 3 plus 4. Okay. In my parentheses, we would end up with 7 because we do what's in parentheses first. There are nothing else first. Do what's in parentheses first. And then 2 times 7 equals 14. You could also plug it in this way into this equation, and then you would get 2 times 3 is 6. 2 times 4 is 8. 8 plus 6 is 14. So that all checks out. Now, what happens when we double A plus B? What does double mean? Double just means multiply by 2. So if we double A plus B, we're going to have 2A plus B. Or in this case, if we plug in our numbers, we would have 2, 3 plus 4, which we already did up there, and it is 14. All right. For example 2, I want you to take about 5 or so minutes and do that with your partner and then come back. All right, you're back, and so is the cat's tail. Anyway, write an expression that is equivalent to double 3x plus 4y. Okay. How can we rewrite double 3x plus 4y? We can rewrite that by putting a 2 on the outside, because double just means multiply by 2. Is this expression factored form, expanded form, or neither? So when we write it like this, it's called factored form. Now, some of you may have skipped this step and gone ahead and doubled it. So you may have already taken that 2 and put it in your parentheses, and you would have gotten 6x plus 8y. This one is what we call expanded form. If you went ahead and did that, that's fine. No big deal. You just might, the next few steps might confuse you. You can just ignore them. It's fine. Let's start this problem the same way we started the first example. What should we do? Well, we should draw a model with 3x, 4y, 3x, and 4y, because we are doubling 3x plus 4y. Let's peek at the next page. How can we change the model to show 2 3x plus 4y? It's kind of what we just did, but we can also put them together. Okay, now it asks, are there any like terms that we can combine in this example? I'm sorry, ask if there are any terms. They're called like terms. When they have the same variable, they're like terms, and we can put them together. So in this case, we have things with the same variable. So yes, we can. We can combine 3x and 3x, and then we can combine 4y and 4y. And we would get 6x and 8y. So that is another equivalent expression we can use to express this. Would be 6x plus 8y, which is the one that if you skipped ahead and went ahead and put that 2 in, that's what you got. So summarize how you would solve this question without the model. So how would you get this without the model? You multiply everything, oh my goodness, in the parentheses, too lazy to write that out, by 2. You multiply all the numbers by 2. All right, example 3, go ahead and take about 5 minutes to do that with your partner and then come back. Okay, write an expression in expanded form that is equivalent to the model below. So this one's different because we don't have a number where we had a number before. Now we have another variable. So we got to put the y in there. So it'd be the same thing as y multiplied by 4x plus 5. Okay, this is in factored form because it's got our number on the outside. Now we have to put our y into the equation, so we multiply everything by y. If we multiply 4x by y, you get 4xy. And then 5 by y, we get 5y. You guys already know, and hopefully you remember, the number comes before the letter. Don't forget that. The number comes before the letter, okay? If you had 4yx plus 5, I would count it right. That's fine. That just won't be the option you would have seen on like a multiple choice test. Kat's going to have to go soon, guys. All right. Example 4. Go ahead and do that with your partner. That'll take you like a minute. So get that done. All right. You should have gotten that done with your partner. Pretty easy. You take the 3, multiply it by 7, you get 21. Put our d back for our variable. 3 times 4, 12e. So 21d plus 12e. All right, you have exercises 1 and 2 on the front. For 1 and 2 on the front, you have to draw a model a model and write the equivalent expression. And then for 3 through 8, you are just going to write the equivalent expression in expanded form. So take about 7 or so minutes to get that done, and then we'll come back and go over it all together. And I'm going to get rid of the cat. All right, welcome back. For number 1, you should have 3x plus 3y, and your model should have 3 sets of x and y. For number 2, you should have 8h plus 4g, and you would have 4 sets of 2h's and 4 sets of g's. For number 3, you should have 8h plus 3. I'm sorry, 8h plus 24. You would have multiplied the 8 by h and the 8 by 3. Okay, for 4, you should have 6h plus 21. For 5, 15x plus 45y. For number 6, you should have 44h plus 12g. For 7, you should have 7kj. That little j is over here in case you missed it. And then 12mj. And then for number 8, you should have 9ba plus 13a. All right. Today, I want you to do your problem set independently and then get it checked. I am certain that Coach P will be able to help you with anything that you need help with on this one. But if for some reason she can't, just make a note of it on the bottom of your problem set, and you can ask me when I get back on Monday. Nope, you can ask me when I get back on Tuesday. So I will see you guys on Tuesday. Have a good day.